Please welcome Tobias Petry.
So, Luke ruined my introduction this morning, like you heard of this weird database guy. And I'd say, personally, it's really awesome. Like, as he said, 2 years ago, I was here in the neighbor building on my first LARACON ever, and now 2 years later, I'm on stage. Like, isn't that awesome? It's that what makes Laravel so great. You have new people coming in all the time, sharing their knowledge, and everyone is just happy to hype them up, to make them better. And that's what's making this ecosystem so great, in my opinion. So I want to make this short, because this talk isn't about me, it's about databases, my favorite topic. But I still have to introduce myself for some people. So as everyone here, I'm a Laravel developer. Recently, I switched more to being a database educator, sharing my knowledge in tweets and articles, and a database consultant, helping teams fix their performance problems when they don't know anymore what to do. And on the image here, you can see me receiving the MySQL Rockstars Award from Oracle for all the educational stuff I share for developers. So the point is, why do I believe a database talk is important here? And Jack Ellis from Use for Them has summarized this really great in an article. We always ask whether Laravel can scale, whether PHP can scale, whether you should use something different which is better suited for that. But the real thing is, Laravel won't be your problem. It's pretty fast and doesn't have to be faster. If you can't do enough HTTP requests, you're just adding another server, no problem. So the real issue is always your slow database queries. That's where we have to focus on. And just adding another server is not that simple, because a database is not stateless. So I can't do live code, and databases are a little bit technical. So from now on, we are switching into story mode. I'm talking about a hypothetical startup that built a shopping application where everyone can create a shop to sell LARACON US tickets, LARACON merch, like the nice Laravel elephant, and so much more. So this startup has been doing good. The product is great. They're getting more and more customers and earning more and more money, which is awesome. But as you can imagine, the more the application grows, the more problems they get. Like on shopping events, the site is getting slow because of all the requests. On Black Friday, the system even crashed because they couldn't handle all the load. So if they want to keep their customers, they have to do something. They had to solve the database issues. And that's when they asked their friends and peers what they should do. So when you ask 10 people, you're getting 10 different ideas what you can do, different products, different solutions, and like Clippy in the old days, it's not helping you at all. Because which of these opinions is the correct one or the best one for you? And the answer is, all of them are right. Because there's not a single solution that is fitting for everyone. Like everyone here in the audience is working on a different application, they have different needs, so there is no silver solution that works for everyone and every problem. There's a different thing you have to do for everything. If anyone tries to sell you a solution that it's working for any application, they are just lying. Which means, at some point, definitely we have to scale to multiple database servers, as we will do in a few minutes. But honestly, you should optimize your application first. Because multiple database servers on handling all of that is a lot more complex than just fixing the dumb things or legacy things you did in the past. And that means that startup, and like you, had to find all those slow SQL queries added indexes for that, rewritten them, changed schemas, the typical things you do. Once that didn't work anymore, they had to add caching. Because what's better than a fast SQL query? One that you don't have to execute. But again, this database has been growing and growing. Each of these steps helped. But at some point, they had to do another thing. So they upgraded their database server, give it more cores, give it more memory. And yes, some people in the audience will think that's just throwing money at a problem. That's kind of true, but not completely. It's true if you didn't optimize your application first, because then it's just wasted money. If you optimized everything before, then it's a wise investment, because a database can easily handle a terabyte of memory, give it. Tens or dozens of cores is no problem. They will use that. So give it that. There's no reason you can't upscale the database. But as I said, this company had been growing, so even a single database server got too expensive at some point. So they had to use a different solution, something that is designed to work with multiple servers. And they found something called Multimaster replication and implemented that. It's a very simple thing, and we developers really love that idea. Because we have two database servers, they always have the perfect same data, which means we have some kind of a backup if the other one is dying, and we can use any of the database servers however we want. Just use by random one of the database servers and set your Laravel connection to that. That's all you have to implement, like 5 lines of code. So how does the internal workflow look like, and where are the problems? So for every request, you're just selecting one of the servers. Like we're sending the right request to the left primary server. That one is doing the change. It's propagating the change to the other primary server. That's also applying the change. And then sending a response that the change has been applied. And only now the primary server will mark the query as finished and tell the Laravel application that the query is finished, which means we are waiting for both of the servers to have the data applied. Which is awesome because we get a nice concept called read after write. We can directly run a write query on one server and read it from the other one. No problem, so very easy to implement. Did it help the performance? Obviously, we have 2 servers. We can now do twice the amount of SQL select queries. But what about changes in the database, like inserts, updates, deletes? Somehow, the number dropped, and that seems kind of strange. So what happened here? So for a moment, think of the application. We have 2 different HTTP requests coming in to order LARACON US ticket. So 2 different independent HTTP requests, each selecting another database server and sending just an update query to decrease the amount of remaining tickets by 1. So these queries are sent to the servers, they apply the change, like before, and propagating, it stopped. Wait a second, that shouldn't happen. And propagated that change to the other server. But now there's a problem. As we have been running independently queries to change the same data on both servers, they can't apply the change because they received information that the tickets may be decreased from 400 to 399, but their local data is already at 399 because they also applied the change from a different request. So they are answering with a conflict response. I can't do that. I'm aborting that query because it's conflicting. And that's sent back as a query response where you get the typical error like, sorry, this query hasn't been executed, there's a conflict. And that's why the write queries decreased. But I want to make this very clear. This application has been chosen for a good reason, because it's doing a lot of writes concurrently on the same data. Your application is probably different. Most applications are doing many selects, but not many writes, and not concurrently to the same data. So this approach wouldn't be a problem for them, and you can use that. That's why I said there's no solution fitting everyone. So you could use that, but this approach is no longer available in any cloud, so you have to use a self-hosted one, which that company decided they don't want to do it anymore. And it didn't solve the performance problem, as performance decreased. So, as we all developers do, we look for the next thing. So they discussed that and have chosen to use read replication, which is the most used approach in all of the applications. Like if you're creating a read replica, a read clone, or however a cloud will name that, that's exactly this approach. The idea is kind of similar, but this time you're just writing to one primary server, so you don't have the conflict problem anymore. And you can add as many secondary servers as you want to, where the data gets asynchronously copied, and you can use them just for reading. So to see it again, like how the workflow looks like, we are sending the write query to a primary that's now directly answering us that the query has been finished, and the data is asynchronously in parallel sent to the secondary server. So this time we don't have to wait for all of them to apply the change because it's asynchronous. But this asynchronicity has a problem. Now imagine that we are again creating an order in the shopping system. We save everything, we're sending the query, and we are getting the response back, everything works. So from our point, that HTTP request is finished and everything is great. And now you have the idea, great, maybe I should redirect to a success page where we display some information about that order. So a completely new HTTP request, and as you're only reading data, you're now selecting the secondary server. And we are asking that for the order ID we sent in the URL, to send the query there to get the order information. And obviously, as the data has not been propagated there yet, we are getting an error response. So from a user experience endpoint, this is really bad, because now we are telling the user that his order does not exist. And that's something almost any application misses. If you use read replication, you have to account that the data you've written at your primary server is not available at your secondary server. And that you have to plan for. Like, there are many different steps you can do. I can't share all of them. Like, for this approach, you could make something easy. When you create the order, you could write in a cache that this IP address would use the master server for the next 60 seconds, and the new HTTP request would look again in the cache if there's information to use the master server and not the secondary server, and read from there. You probably have to do different things for jobs, for events, so there's always something you have to plan for. And there's a different implementation for every application. That's why there's nothing in Laravel to do that automatically for you. It's doing that automatically within one HTTP request, that after the first time you've written to the primary, all reads are going to the primary, but across HTTP requests, it can't do anything, as it depends on the application. So some people had the idea, maybe we don't do this asynchronously, the propagation, we do it synchronously. Now imagine we have these 5 secondary servers, and the data, our write query, is propagated synchronously to there. So as you can see, the data propagation is happening at different speeds, because maybe the server's in different location, different data center, network issues, and even the computation time to apply the change is different, because maybe one of them has some hardware issues, and many thousand things can happen why it's not instant. So if we would change that idea to synchronous replication, In this case, for a single write query, we would have to wait almost 18 seconds until that query would have been finished, which means our whole application appears to be down, as every write query takes almost forever, just because one of the servers is slow. And the more servers you have, the more probability increases that there will be one slow one. So some people had the idea, great, maybe we don't wait for all of them, we only wait for the majority of one. So if you have one slow or two slow ones, we just don't care. They are then asynchronous, which means you still have to account for the data consistency issue. The data is not there, but the problem will be less important, as most of your servers will always have this data. So as you see, it always sounds simple, clicking a button in HWS, in Vapor, that we have a new read replica, but most applications will then get some issues. And you have to plan for that. But did performance look good? Obviously, yes. For every read replica or secondary server we add, we are getting more selects, and we are back to the old one with write performance, because we don't have a conflict problem anymore. And if you add another server, we are getting more reads, which means you can perfectly scale the read amount by just adding more and more servers. Like adding 15 or 20 servers is not a problem at all. And again, for most applications, this is perfectly okay because you don't have a ton of writes. But as you can see, the write rate stays slim at 1 times the server, which is clear because we're always writing to the same server. So some applications, not most, like only a tiny fraction, have to increase to something more advanced, which is when they migrate to something called sharding. The video didn't start. No, wait a second, it didn't start. Imagine it moving. So the idea is pretty simple. You separate all your data and move it onto different servers called shards, which means our LARACON ticket store is now on shard 1. Our Laravel Elephant PHP store is now on shard 2. So we can distribute all the writes to more and more servers. And if that is not enough anymore, you're just adding more shards and move some of the shops to these servers. So how would you do that in Laravel? Most often, now it's moving, most often you're adding another server, which is most often a Redis server. And I call it a Redis server and not a Redis cache, because you want this one to be persistent and never lose the data. Why? Because we're using it to store mappings. So for every HTTP request, we are asking the Redis server, hey, on which shard is the LARACON ticket store saved? It's answering, great, that's on shard 3. So we change the active database connection to shard 3 in Laravel and just run now all our queries on that shard. Pretty simple. But it's always only simple if you don't look at the details. And that's why I did this talk. Because before, with read replication and with sharding, everyone is omitting the details that could hunt you weeks and weeks if you don't know them and don't account for them. So now someone in that startup had the idea, great, let's build a UI where I can see all of the orders. So every customer can see all of the orders across all shops, which means a query like that, like from the users joined to the products they bought. But that's the problem. Where are the users stored? We separated all our data by the products, but users is not fitting into that concept. So what you have to do is create a new database. Like now we have our sharded system for shops, another database for users. Maybe your application will have another database server for another concept. But we are not done here, because every order is creating an entry in the user's board table, which means we also have to do a ton of writes into that table. So we make this a sharded system too, to sustain all the load. And as you can see, complexity starts to increase and increase if you look more close to what you're really doing. But this wouldn't be fun if the problems are solved yet, because there are more of them. We still have to join, in this example, to the products table to get the product name, the product image, and product description. But how should we do that? Because the products table is on a different server. Wait a second, it's not on a different server. It's on 3 different servers. So we should have to join 3 different servers. How do we do that? We can't do that as we can't join across multiple servers. So we now have to implement that logic in PHP, in Laravel, with our relationships. That's, in this point, easy, but more and more joins you have to do, you see, it's getting quite complicated efficiently getting all the data, because now we have to run a query 3 times, one after another, for each of the shards to get products from there if some bought products are stored on these shards. It's not that simple. Sure, there are solutions to that. Like there are products like Citus for PostgreSQL or Vitesse, invented by YouTube and now maintained by PlanetScale and used in PlanetScale enterprise plans, that's doing all of that for you. Like you only see a virtual database server and all the sharding stuff and moving stuff when one shard has too much data, and running the joins on different servers. It's doing all of that magically for you. But you have to use these solutions, or you have to do it by your own. But again, it's not that simple. So the point is, So for the first time, we can now see perfect scaling. Like with the 3 shards, we are getting 3 times select performance and 3 times write performance, which means we can now scale infinitely and don't have a scaling problem anymore. And if we need more selects, it's no problem. We can turn every shard into a replicated system to add read copies to every one of these shard masters. No problem. But quite complicated architecture. So, and I know all of that sounds complicated, and I didn't want to make it complicated. But I wanted to warn you of the issues it can have. Because otherwise, you will try out these solutions, and I had enough clients that later on went to me and said that they have these and these data issues, and if you look closely, like for read replication, it's always the data not being there, and there's wacky workarounds you have to implement. So the idea is to keep it very simple. Stay on a single server as long as possible, use then read replication, and for the few applications that need more, move to sharding. Even companies like Notion or Airbnb, having millions of users, had been working perfectly great on a replicated system until they had to move to sharding. And if you try to do these steps too early, it will feel like that. Because scaling an application, not even a database, is always a hard task. You always have new and new problems. And you definitely want the most easy solution of your tech stack to solve these issues, which means don't plan for too far to future load. Stay at what you have as long as possible. And if you want to stay as long as something possible, stay on a single server. And I personally have written a book for that. I've written the book Indexing Beyond the Basics, which is teaching indexing knowledge in a new and novel way with a lot of illustrations and graphics that can help you stay on a single server as long as possible. And until end of the week, the book is 30% off with the discount code LARACON. So if there are any more questions, always feel free to reach out here in the area or drop me a message later on. I'm always happy to help. Questions?
I have questions.
Okay.
So, Mr. Gummy Bear, aka Tom, is asking, how do I scale my database if I have a write-heavy application without tenants?
That's really hard because, when you don't have tenants, the typical sharding approach doesn't work. But you can do it differently. Like, normally, sharding is thought of moving the full data, like products table, products images table, to a new shard. But you can do it also per table. You can say the products table is on this server, the products images table on that one. So you can scale it just by table. But obviously, there's at that point a limit, because if you have 20 tables, at max you can have 20 tables. And then you have a problem. Then you have to look for something new, how you can split your data.
Thank you. And Zasha is asking, I would like to hear, or questioning, I would like to hear from Tobias which SQL client he's using.
Which was?
SQL client are you using?
Client. I'm personally using Table Plus. Yeah.
You got some fans out there. And
Anonymous user.
Oh, you know that guy.
Not yet.
So the anonymous user is asking, at your home, how many tables do you have?
At my home there are two, like one to eat and one for where you put your stuff in the living room.
So we can say that you limit
by 2 apartments at most. There can't be more. Oh, 3, a desk to work on. Like I can have 3 apartments.
Do you inner join the tables when you get people?
No, with sharding you don't have joining. You didn't.
Or you left join or right join?
Yeah, move to different apartment, take it there and move back.
Where something's happening.
Exactly.
Yeah, good conversation, man. A big applause for Tobias.